Welcome to our next episode for optics. We are continuing with eye defects and we are studying more about prescribing lenses. So our example number 4 says that Miss Judy, a senior teacher in Lake Kangaroo High School, can see objects clearly only if they are between 70 centimeters and 500 centimeters from the eyes. Her optometrist prescribes contact bifocals that enable her to see distant objects clearly through the top half of the lenses and read students' papers 25 centimeters from the lower half. What are the powers of the top and bottom lenses? Before we go any further, let's try to analyze the question very well. So this lady is a teacher and she can only see between 70 centimeters and 500 centimeters. Optometrist is a specialist in studying the eye defects and then also prescribing lenses which are supposed to correct the defects of the eye. Here we see that if Miss Judy can only see between 70 centimeters and 500 centimeters, it means that she's both short-sighted and long-sighted. She cannot see beyond 500, meaning that that's the far point that she has, that's the farthest she can see, and then she can also not see below 70 centimeters, implying that that is the closest that she can see. Remember, in our previous lessons we learned that for the normal eye, a person should be able to see as far as infinity, where infinity here means very far, like you can see the moon, you can see the stars at night, you can see the sun, so that's how infinity is. And then for a normal eye, you can also be able to see at 25 centimeters clearly without straining your eye. So she really needs a clear prescription of the lenses. Okay, so we have two parts. If this is the lens, it has two parts. There's a lower part has focal length f1 and there's a lower part has focal length f2. Therefore, the two have different powers. If we look at on the diagram on the left, this is the eye. So the eye is placed here, and then since she can see she cannot see beyond 500 centimeters, let's say that this is 500 centimeters. And then the question also says that this is a contact bifocal, so we say that the lenses are in contact with the eye, so there's no distance between the lenses. Therefore, we shall place the lens exactly here. Place exactly here. So let's say that this is the lens that we have. Then she cannot see beyond 500 centimeters, but we want this lady to be able to see at infinity. For her to be able to see at infinity, it means the D object is supposed to be infinity, and now we need the lens to place here at the eye so that it can bring objects which are at infinity and focus them at this point, which is now supposed to be the far point. This is the far point of uncorrected eye. So basing on this, we know that 1 over f is 1 over d object plus 1 over d image, and that is the same as power if the distances are in meters. So this is going to be 1 over infinity plus 1 over distance here, which is 500 centimeters, and it is supposed to be 5 meters. So let's check something very interesting. If the lens is here, this is going to be the image. Image is supposed to be focused at the far point of the eye, which is uncorrected, and then this is the object. The image and the object are all on the same side of the lens, therefore the image is virtual. That's why this is going to be negative, and this gives us the power equal to negative 0.2d. So being negative, it means that this lens is supposed to be diverging, so the top half is a diverging lens. On this side, we have This person cannot see below 70 centimeters, yet she wants to read the student's papers which are placed 25 centimeters. So let's say that the paper is placed here, 25 centimeter. This is the eye. We shall place a contact lens here. So we want to know what should be the lens, the nature of the lens, and then what would be the power. We know that this person has a near point of 70. So the near point, this is a near point of 70. We want to place the object here, object placed here. So when the object is placed at 25 centimeter, the image has to be formed at the near point. If we place the lens in contact with the eye, the object and the image, which is here, image are going to be on the same side as of the lens. Therefore, this image is going to be virtual. If we use 1 over F, which is power, equal to 1 over DO plus 1 over DI, this is going to give us 1 upon the object, which is 25 centimeters. Now you write 0.25 plus 1 over negative 0.7. So this gives us power as positive 2.6 D. So we have a positive, so meaning that this lower half of the lens is a converging lens and has to be with the power of 2.6 D.